When you solve an equation, there's usually only one solution. If you're solving a typical linear equation, you get like x equals 4 as your answer, and you're done. When you're dealing with inequalities, though, which we will be in this section, we have many answers that are possible in the problem. For example, on this first problem here, we have x is greater than 0. So all the numbers that are greater than 0 work for x in that problem. There's not just one answer. Anything like 2, 7, 54, 1 million, those are all answers because they're all greater than 0. So we want to be able to show that on a number line. And the way we do that, x has to be greater than 0. We want to shade, because shading shows where the solutions are, all the numbers that are bigger than 0. So at 0, I'm going to put an open circle because I don't actually want 0. Our number has to be greater than 0. And greater than is going to be all the numbers going this way. So I'm going to shade like this and put an arrow to show that that keeps on going. So when I look at that number line there, based on the shaded part, I see, okay, 0 is no good, but everything bigger than 0 works in my problem. On my second problem here, this is x is less than or equal to 1.5. So 1.5, this time it says or equal to. That's what that little line down here means. That means 1.5 itself is okay. So I'm going to make a solid circle on this one at 1.5. All the numbers less is this way, than 1.5 are solutions. So I'm going to shade that portion of my number line and draw an arrow on the end to show that everything from here to the left is a solution. With these first two problems, a shortcut that kids tend to, that they hear early classes that they tend to remember in Algebra 2. Silly way to remember this if the solid versus open circle is no good. If you use extra ink on your graph to draw on that extra line here, you're going to use extra ink to make the circle solid. We use less ink here, so we use less ink on our circle. And if your variable is on the left, the inequality sign kind of points the way you're supposed to shade. Here, if you look at this like an arrow, it's pointing this way, so we shade it to the right. Here, it's like an arrow pointing to the left. If you do choose to do the problems that way, I want to really caution you about problems like this, where your variable is on the other side. So, you could do this problem like this. -2 is greater than x, and figure out what that means. I strongly recommend, though, that you rewrite the problem so the variable is where on the left like we usually have it. So my x is going to be on the left here, and my alligator still wants to eat the same number. So the alligator is still going to eat the -2. These mean the same thing. So I flipped this part around, and the sign changed as well. And now it's just like the other ones. Open circle at -2, shading to the left. I have a couple more examples on this video that are compound inequalities. So these ones here are just one little piece to them. Compound inequalities typically have multiple pieces or multiple inequalities within the same problem. So compound inequalities have multiple pieces. So on my first problem here, it's x is greater than 2 or x is less than or equal to 0. So if either one of those parts is true, it's going to be a solution in our problem. We'll take the numbers that are bigger than 2 or the numbers that are less than or equal to 0. Any of those are totally fine for us. So at 2, I'm going to put an open circle right here, and I'm going to shade it's greater than 2. So that part's going to get shaded like this. My other part here, x is less than or equal to 0. Well, there's 0, solid circle. Less than or equal to goes like this. So what I really have going on in this problem here is an arrow going in two different directions. We have one part going this way, one part going this way for my inequality. For my next problem over here, I have x is greater than or equal to -3. So greater than or equal to -3 would be right here. Greater means I'm going to shade to the right. So this all gets shaded right here. Or x is less than 1. Well, here's 1. I could technically put an open circle here, but because it's already shaded, I don't even have, it's already been covered. I don't even need that open circle because it's already been shaded by this guy. And we're going to shade to the left. So really on this problem, we have kind of two overlapping pieces from here to the left and from here to the right. The whole entire number line is shaded on that one. So the entire thing got shaded by either one inequality or the other. Now, with these OR graphs right here, I'm kind of proud of this. This is a little way you can keep straight what the pictures are going to look like. If you look, the most common type you'll see with OR inequalities are graphs like these. Picture if I drew in right here, like a little boat, and give me a little like stick guy standing on the boat here. He's holding out two oars on either side of his boats. OR graphs typically look like the oars on a boat. That's pretty cool, right? Hopefully that'll help you guys remember things. I was pretty excited. I thought of that myself. So yeah, on my bottom two problems here, I have AND inequalities. And on an AND inequality, both parts have to be true. So this means that x has to be less than or equal to 4, and x has to be bigger than 1. Both of those things have to work. In an OR inequality, it's kind of one or the other. But AND, you need to have both. So I want numbers that are less than or equal to 4, and bigger than 1. Well, that's just going to be the numbers between 1 and 4. Like 2 and 3 would work here. So, open circle here, because I don't want 1. Close circle here, because I do want 4. And all the part that gets shaded is in between part right here. Just that little piece, because these are the only numbers that are smaller than 4 and bigger than 1 at the same time. So this graph is like a little line segment. And on my last problem of the video here, this is another way of writing an AND inequality. We have kind of a combined problem right here with two pieces to it. If it helps you to think about it this way, you can cover up one of the pieces at a time. Like if I cover up that part right there, I just have x is greater than -2, or -2 is less than x. So we want numbers that are bigger than -2, and at the same time, less than 5. Again, I call these sandwich inequalities. It's not an official word. This is the same sort of problem as an AND inequality, but basically x is trapped in between -2 and 5. X has to be bigger than -2, but has to be smaller than 5. I'm going to do the same sort of thing. Open circle. They're both open circles on this one. And the only numbers that work are the ones shaded in between. So just this part right here is my solution.